Now we introduce a spatial transformer network. Spatial transformer network provides a spatial transformation that converts an input image to output image with a different shape. That means if we have a object, image, or a different character, not in the regular shape or regular position, which cannot be recognized or classified by the neural network. So the spatial transformer can find a way to correct them, output in them as a regular positions. For example, this input image is called U, and this output image is called V. For the identity transformation, just transfer the shape from U to V is nothing changed. Just get the same position, same shape. But the spatial transformer is a different way to find a transformation matrix or parameters. We can change the position from input to output image. The spatial transformer is included the three models. First, this input image uses your localization network to find the parameter, transmission parameters, theta. From theta, we find the regular, the sampling grid. In this grid, we can find the corresponding relation from input to the output. This grid is in a regular shape. The dimension is the same as the input, and then we get this grid, this sampling grid. From the sampling grid and the input shape through a sampler. That means first we need to find the pixels in the input and the regular output image. What's the relationship between the pixels and the sample? So the sampler, we can find the value in the output image. So finally produce the output image like here, like in this way. Like I mentioned, one spatial transformer includes three parts. One is the localization network, one is the grid generator, and the third one is the sampler. The first one is generate transformation parameters. The grid generator pixel distribution, which corresponds to the pixels in the input image. Finally, we use the input feature map or input image and the sampler grid as the input to the sampler. Sampler then produce the output image. Like here, for example, this is number 2, this is number 4, this is number 3. Is the original shape because it's distorted or it's a wrapping. Also, we cannot use the regular classifier to classify these letters. However, use a spatial transformer, we can, from them, transfer to the regular shape, regular position. We can easily use a regular classifier to recognize what's the, they are, or what's their classification. So like here, we read the number on the street. In the original format, maybe easy, not easy to recognize, but after the spatial transformer, we can easily, recognize these numbers. What are the really meaning? Meaning just means, for example, this S means the coordinates of the source pixel, and T is the coordinates of the target pixel. For example, in the original, in the input image, so we find each pixel. For example, we can express as a transformation tau. This tau can be split into two parts. First, this fine transformation matrix plus target. Target means here the pixel distribution location is here. So the localized network is trying to find this matrix. Using this matrix, we find this source location and the target location. We can find the relationship between them, and get the correct shape. The shape just show the relationship pixel in the input feature and the output feature, but we also need to calculate the value in the output feature map. That's what we need for the sampler. The sampler, for example, we need to calculate the value at the different position in the output feature map. Let's say V. This V, for example, we give a index. This I is just a total number of the pixels inside the output image. This U is the value at different at M, and U is 2D M and N and M. Local, the coordinate, the location, we know, what's the value. Here is the kernel. How can we, sample the input, the pixel value inside the input image? Then we, convert the value at M and U to I to get the value at different pixels inside the output feature map. So because this is like also serve as the objective function. So to train this spatial transformer, we can use the back propagation method to train the network. For example, we can calculate the derivative of objective function with regard to this U, this X and Y. Then we get the correct output, which can be recognized by regular classifier. For more detailed information, please check these references. Thank you.